Hello everyone. This is Sadhana Alangar, HL7's Director of Education. Welcome to this session on protecting FHIR data by Himanshu Chavda. We are first going to play a recorded presentation, and Himanshu is joining us online to take questions. So he will be answering the questions in the end. At this time, I'm going to request that the recording presentation be played. Thank you.
Hi, welcome to FHIR DevDays. This session is on protecting FHIR data. My name is Himanshu Chavda. I'm a healthcare specialist, part of Google Cloud's Healthcare and Life Sciences team. In this presentation, I will present a reference architecture of data loss prevention, it's called DLP, to detect sensitive data such as protected health information, PHI, in FHIR using three techniques: discover and classify, de-identify, re-ideate risk analysis. These techniques works on structured and unstructured data at rest and on real-time transactions. Key topics include the identification can be in many forms. One is called masking, tokenization, and date shifting. When we talk about DLP, it's a pretty industry standard term, but it's mainly it means it's a process in which a given organization tries to implement a process and ensure the sensitive data, like personal health information data, is not lost or misused, or it's not by accessed by an unauthorized access. This data is stored in various forms. One is structured and unstructured. So this process helps organizations to understand and identify how do you discover and classify such sensitive data, and how do you run through re-identification analysis to do risk anomalies. The identifications also has helped to reduce the risk of inherent in data, which means that including masking, tokenization, redaction. So the data is stored in structured or unstructured formats. In order to do that, you need some automation or some processes that helps you understand data to be identified and classified as a sensitive data. There are a lot of processes and tools out there. One in which that we have here at Google, we identify based on the specific classifiers that includes all PII information like name, location, dates, passports, any personal identifiable information that can trace it down to an individual. So there's also called documents classifier, like if you have some clinical documents that is stored in some format in the EMR or clinical applications that you want to run through some internal processing of analytics use case or some other use case on cohort analysis, or do some additional data warehouse kind of a data mining level of a use case for your personal clinical use case or internal processes that helps you understand. So the ML-based documents classification helps you identify documents that are coming into in your application or in your environment, and how you automatically trigger them and identify them. How do you run a de-identification process on those documents? And there's some custom classifiers that helps you build a dictionary based on a specific pattern that you see in your native to your organization. So the identification, by definition, is the removal of personal identified information, PII, from a data such that the individuals that the data describes can no longer be identified, but the data retains its utility for research and for commercial use, commercial product development purposes. So the identification is a very powerful technique. So HIPAA has some guidelines around it, and mainly it allows you to leverage for secondary use, such that it can be used for comparative effectiveness of studies or policy assessments or some sort of life science researchers, and many more use cases within a clinical context. There are two approaches that HIPAA has listed in here. One is expert determination, and the other is called safe harbor. Many of the organizations use safe harbor approach or method, especially because it's mainly unstructured data. But many use that the expert determination may be more appropriate on some of the complex use cases, such as unstructured data that comes in a notes or some sort of a DICOM data or some sort of a data that is not stored in a proper structure like a database or like a FHIR JSON object. So the example of the identification, you may have come across various use cases in your own experience. That a patient in here is an example that it calls a doctor's office to schedule an appointment and provides his or her own personal identifying information like SSN, and gives some sort of an encounter information about what they're feeling that morning or that afternoon or something, and they want to get at some sort of immediate care, and they leave their phone number. So in this case, data is stored in raw text inside into the some clinical application, but the data is at rest or in transit, can be accessed by some third party or unidentified or unauthorized access. So how do you protect that data? So that I will walk you through in this approach. In this example, it shows like character masking. So it replaces the entire context of conversation by some asterisks or some special character, whatever you define as. Or you want to keep the context of the conversation, but yet you want to preserve the identity of the patient by providing a masking of specific values. And also you want to do some sort of additional masking of data with a different set of criteria that you want to do. So in the identification processes, they have many techniques that are out there. They're here, some of the a few techniques that I've listed out here. One is to redact or remove data by masking the entire blob of data with the specific characters. Or there's a specific way to replace only sensitive data with the fixed characters, which is called character masking. One is called replace with some sort of a type of data that you want to replace the input category by a specific label. For example, in here, it's like a John lives his number on the voicemail, but John is the name of a given person. So it replaces by what type of data it is replacing with, or input type. The date shifting is another random number of days with an option of maintaining chronological order of the date belonging to a given patient or a population. Meaning you de-identify the date by specific encounter, but you want to preserve the longitudinal information of a given encounter of the historical information as well. And the last one is it's fairly common in some ways. It's called crypto hash, replacing input with an hash value by guaranteeing of using a same customer defined encryption key, which allows an organization to maintain their own security. De-identification enables many use cases in healthcare context. One is that doing a clinical research, some sort of an analysis on a given data. So you cannot do the research on raw data that has PHI information in the raw context. In order to do that, you want to de-identify the data, and you want to securely exchange between application or users to how do you run the cohort analysis. So de-identification enables you to do that, and also helps you to read that data. It's one way to do it by, for example, and if you're writing a new application and you want to preserve the data, the context of the data, but not necessarily expose the identity of the individuals in this case. So that is the kind of power of the identification processes that helps you run through it. In this, we are going to look at the 4 different examples of the identification, which is structured data in table format. How do you de-identify data is in structured format, is in columns and rows. The other way is a structured data in a FHIR format, which is like a specific type of a JSON, FHIR resources in a JSON file format, which is structured at the same time. It contains a lot of PHI or PI information based on its a clinical encounter of a patient. The other is an unstructured data within some sort of a clinical application that some physician writes a blob of data or text inside a clinical text box of an application. And the other one is unstructured data, which is an imaging, it's image data that contains some metadata to maintain the structure of DICOM images, but at the same time, the data is not viewable or even burnt into the image. How do you de-identify that? So in this example, it talks about the data masking, and many of you may be familiar with this in some aspect. which is transforming data into specific de-identification processes that allows you to preserve the data itself by enabling some sort of a masking. So in this example, the first three columns, it's preserving the data at the same time it's anonymizing or de-identifying the data with given character sets. So the ID field, it is maintaining the ID identification field entity, but at the same time it's de-identifying with the generic value. The job title, the phone number, you can see it's called grouping a specific type of data into specific format, and the comments field, where you see unstructured information coming via various form, where you want to maintain the identification of a patient or given encounter context, but at the same time you want to DID. So in here it shows that it can mask the data by specific field value or specific type of the phone number by putting masking of characters, or even identifying the SSN number and updating that with like some full character masking. It's called redaction. So it's more in like a database level, how it looks in the backend. So this is more an example of tokenization. And here in the top left corner, you see a user ID table, a transaction table, which has some value coming in as a raw data, but tokenized value kind of keeps the referential integrity of a given value. At the same time, you inspect and redact data in near real time. So this is an example about how do you tokenize data in near real time. The structured clinical FHIR data, FHIR has, based on the field specified in action, you can, for each field in the FHIR file, you can either skip it or you can transform primarily for structured field, or, inspect it and transform based on unstructured data within a text comment. So with a transform, for further specific action, you want to redact, replace with specific characters or hash. So there are various ways you can do in a FHIR format. How do you DID data? Here's an example of a FHIR resource. This is a patient resource. On the left side, it's an original record. That patient information is listed in here. So this example gives you 3 levels of de-identification processes. One is on the date or address. Sorry, the patient address is kind of left out as a blank from the post-DID process. The date of birth is a date shifted by specific time interval that was defined in this example. And also, if you look at the text field, a text section towards the end of the file, the name of the patient is replaced by the patient person resource name as a field value or the column name. So this gives you an example of 3 different ways of de-identification in one given file resource. So here's an unstructured text. This is another example of how do you near real time, how do you de-identify the data, or you can do some sort of a data anomaly on this. So for example, a de-identification or redact data on a given patient encounter, somebody's calling in. So on the near real time, it picks up the values and updates into the database and updates it with based on the process or logic is defined for DLP process. And unstructured DICOM imaging data, it's a similar way. So DICOM data, you have a metadata and tag configuration and also image and pixel data. So I'll just in a high level give an understanding of what unstructured data on the DICOM perspective looks like. How do you de-identify? There's various ways you can do it. You can identify filters, configuration, and there are other processes like nested tags. How do you de-identify and create a specific type of a keep list or remove list, specific tags you want to keep or delete, or you want to retain it, or you want to redact all, or you want to keep one, so on and so forth. So here's an architecture, high-level architecture I'll walk you through. Data is, in a clinical context, this is the FHIR DID architecture that we have here. So data from the EHR system or clinical applications and modalities, transform data, ingest into the FHIR format. So data is from the native application is not stored in a FHIR most of the time. And so you want to transform into the FHIR. When it transforms in the FHIR ingestion process, you want to store the data in original format in here, it looks like. And you want to run the de-identification analysis that helps you de-identify data based on your catalog of data that you want to de-ID based on your preferences. And that way you can enable clinical application use cases, and also you can do analytical tool use case that allows you to do data, electronic data warehouse, or some sort of a ML machine learning model, or you can do data visualization. So this is a high-level data architecture of FHIR data and data identification. So this is the end of the session. So I would love to hear more from you. You can keep in touch with me. Here's how you can contact me. You can message me via Hua app or on the speakers gallery, or you can email me here or at Zulip chat. And thank you once again. Hope you're enjoying your FHIR Dev Days, and hopefully this was valuable to you.
Thank you very much, Himanshu. I see that you have answered the question online.
Yes, hi.
Do you want to say anything more about that question, or should I ask people in the room?
No, I think that's mainly on like how to protect data. That's what it's not a misnomer. It's mainly on the context is around data is everywhere, and how do you make sure that this data is securely stored and in transit. So that's what made the DLP is mainly on the data at rest, not on the transit, but mainly on the rest aspect of it.
Okay, anybody in the room? Do you have any questions? There's one more question online. Yeah. How do you handle information burned into an image?
Yeah, that's a good question, actually. So burning in images is a pretty common use case for DICOM images. I'm assuming this is related to that context about data in DICOM format where the image has some overlays that are burnt into it. There are certain aspects of optical character recognition that can be utilized to capture data that is part of the burned image, and you can do a pixel data swap. So that's one way to do it. If you want to know more about it, I can definitely get back to you on that.
Anyone else? Any other questions?
Okay.
I don't see any other question online or in the room.
Sounds good. Thank you,
Going
Sadhana.
once?
Thank you for everyone.
Twice, 3 times. Okay,
Right.
Thank you so much. Thanks, Himanshu. And for those of you who asked, I will post the original recording in Hua. And Himanshu, if you could answer the 2 questions online, that'll be great. Thank you so much for your time. Thanks, everyone, for joining.
Thank you.
And enjoy the rest of your day. Bye, everyone.
Bye, everyone.